Good morning, students. Now we discuss about the first chapter, sets, relations and functions. In 10th standard also we see the sets, relation and function sums. Now we see the sums in the next some more models. We already see in the 10th standard, but we elaborate, we see some more problems. Okay, now we move the first exercise 1.1. Write the following in roster form. You know very well a set can be written in descriptive form, roster form, set builder form. A roster means just we write the elements of the set. X belongs to n. The first submission is x belongs to n. X square is less than 121 and x is a prime number. So it is called the set builder form. Now to convert the set builder form into the roster form. You know very well every set is denoted by the capital letters. It is your choice. We write any letter from A to Z. I will take the first letter is A. Now directly I write, this is all just one more question. We write the set contains x, where x is a natural number, and also it satisfies some condition whose square is less than 121, and also x is a prime number. You know what is the first prime number? 1 is not a prime number and also is not a composite number because x belongs to n. Next 2. 2 is the only even prime number. So the first value of A is 2 is possible because it satisfies all the conditions. 2 belongs to n. Whose square, the value of 2 square, 4 is less than 121 and also x is a prime number. What is the next prime number? Is a 3. Is also possible because the value of 3 square is 9 is less than 121. What is the next prime number? 5. 5 square is 121. 5 square is 25 is less than 121. Next prime number is 7. 7. The value of 7 square is 49 is less than 121. What is the next prime number? 8, 9, 10 is not a prime number. The next prime number is 11. Suppose we write here 11. The value of 11 square is 121. 121 is exactly is equal to 121, but our condition is whose square is less than 121. So set A contains just 4 elements, 2, 3, 5, 7. So we write the set in elements form is called the roster. So what is the name of this form? It is called the set builder form. Now to convert the set builder form into the roster form. A roster means it has exactly how many elements are possible. So according to our given condition, A contains just 4 elements. Now you see all are natural number first of all. And also all whose square is less than 121 and also all are prime number. What is the reason to not write the next prime number here? 121 is exactly is equal to 121. So first one is over. Now to come the second one. The set of positive roots is important. We write the positive roots of the equation. X minus 1, x plus 1, x square minus 1 is equal to 0. Product of these 3 factors is equal to 0 means any one factor should be is equal to 0. Suppose x minus 1 is equal to 0. No need to write for understanding I write. Suppose the first factor is equal to 0. X minus 1 is equal to 0. What about x? 1. Or second factor is 0, sir. X plus 1 is equal to 0. What about x? Is minus 1. Minus 1 is not a positive root, it is a negative root. So you neglect. So you neglect this. X square minus 1 is equal to 0. To simplify we get x plus 1 into x minus 1 is equal to 0. So either x is equal to 1 or x is equal to minus 1. But we have only the positive roots. So I will take the name of the set is B. The value of B, the only one positive root is 1. Minus 1 is also a root, but we need only the positive root. So the positive root of the equation is just 1. So the value of B is equal to 1. The name of the set is not given. So it's your choice. We will take from the set's name from A to Z. Is your choice. So I will take here B. Now we move the third one. X belongs to n, where x is a natural number. And also it satisfies some condition. The value of 4x plus 9 should be less than 52. So I will take the name of the set is C. First of all, we write all values of x are natural number. What is the first natural number? 1. To substitute here. 4 ones are 4. 4 plus 9 is 13. 13 is less than 52. So 1 is possible. Next natural number is 2. 2 is also a possible. 4 2s are 8. 8 plus 9 is 17 is less than 52. So we continue, we move the sums up to the condition is satisfied. In middle I check the value of x is 9. 4 9s are 36. 36 plus 9 is 45. Okay, less than 52. 10. I put the value of x is 10. 4 10s are 40 plus 9, 49 is less than. Suppose I put the x value is 11. 4 into 11, 44 plus 9. 44 plus 9 is 53. The value of 53 is more than 52. So all values of x should be its condition the less than 52. So the value of x is start from 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this 10 value is only possible according to satisfy this condition. You check anyone. Suppose I put the value of x is 6, 4 6 24. 24 plus 9 is 33. Is less than 52. So the starting value is 1 and the last value is 10. Why I stop 10 here? 4 10s are 40 plus 9, 49 is less than 52. Satisfies the condition. What is the reason to don't write the next element 11? 4 11s are 44 plus 9 is 53 is more than 52, but our condition is less than 52. So in this set the roster form contains 10 elements from 1 to 10. You try the first solution. It's also a set builder form. It contains just x. But this x satisfies this condition. Important is given x belongs to R is except to minus 2. What is the reason to give this condition? Because to exactly we put the value of x is a minus 2. You see the value of the denominator is vanished. We put the value of x is minus 2. Minus 2 plus 2 is 0. Any number by 0 is an indeterminate form. So what is the suitable value of x? Where x is a real number, we don't put a x except minus 2. We check what is the value of this one, and also this expression have just 3. So is your choice. X belongs to R. R means real number. We put a rational, irrational or any number except this minus 2. But if we substitute the value of x here, it satisfies the condition, the answer will come exactly 3. You identify the answer? I say it has only one element. What is the element? What is our final answer will come? 3. So we replace any value of x. Suppose we put the value of x is 0. Numerator is 0, denominator is also 0. So what is the answer? Minus 4 by 2. We can also make it minus 2. But minus 2 is not is equal to 3. So we check one by one. The suitable answer of x is minus 5. The value of x is minus 5. The just answer is minus 5. How it comes a minus 5? I check. I replace the value of x is minus 5. So minus 5 already minus 4 by minus 5 plus 2. What is the value of the numerator? Minus 9 by minus 3. We cancel, we get 3. So the answer is minus 5. And also it satisfies all the condition. X belongs to R. X is a real number. And also the value of x is not is equal to minus 2. Minus 5 is not is equal to minus 2. So the suitable answer of A is equal to minus 5. So this is a working rule to convert the set builder form into the roster form. Roster form is all the sets having just the elements. Now we move to the next one. Write the set minus 1 comma 1 in set builder form. Just one set is given. We write in the set builder form. That is in the previous one, reverse. Roster form is given to convert it into a set builder form. I will take any of the letter from A to Z. I will take this E. In set builder form is x. First of all, I will take it is x. E is a real number. I will take x belongs to R. X is a real number. It satisfies one condition. Okay. X square it should be is equal to. We put any value of x here, but whose square will come 1. So just we put the value of x is minus 1, whose square is 1, and plus 1, whose square is 1. Except these two values, no one value can have whose square value is equal to 1. Roster form is given. Whose relevant the set builder form value is x belongs to R. X is a real number, and also whose square is equal to 1. Okay. Now we move the third one. Allow one more. Finite or infinite. It's also see in the transistor level. All are given in a set builder form. Now to convert or to write is a finite or infinite. You know what is meant by finite and infinite? The number of elements are countable, it is finite. The number of elements is not countable, is going on. Then we say it is a infinite set. The first one, x belongs to n. That means x is a natural number. X is an even prime number. You know very well what is the only even prime number? That value is 2. So just only one value is 2. Therefore the set is a finite set. So I write the values here. It is a finite set. Because it contains only one value. The value is 2. 2 is the only even prime number. Therefore it is a finite set. Second one. X belongs to n. X is an odd prime number. Odd prime number is going on. So it is endless. The process is endless. The starting x belongs to n, x is an odd prime number. What is the first odd prime number? 3. Next 5, 7, 11. So it is going on. Therefore it is an infinite set. Second one is infinite set. Third one, x belongs to z is important. Z means integer. The set of all integer. X is even and less than 10. Okay, what is the less than 10 number? 8, 6, 4, 2. And also x belongs to n is an integer. So minus value is also possible. So minus 2, minus 4, minus 6, all values is possible. Therefore it is also an infinite set. You identify the 4 and 5 using the same model. 4 and 5, what is the answer? X belongs to R means real number. X is a rational number. So we can form so many rational number belongs to the real number. I say one example, 1 by 2, 1 by 3, 1 by 4, 1 by 5. So the process is going on, is endless. Therefore it is also an infinite set. Fifth one, x belongs to n. X is a rational number. X is a rational number. We write any number in rational form. I write 1 is also a rational form. How to write? 1 by 1. 2, I write 2 by 1. 3, 3 by 1. So we write any rational number is also a rational number. So this process is also endless. Therefore this one is also an infinite set. Now we move the next question, a fourth one. By taking the suitable sets A, B, C. So we take the sets A, B, C. I verify the following results. So the set A, B, C is not given. Is your choice. Will be take any values of A, B and C. But important, we will take the one finite number of minimum number of values. Because some Cartesian product are involved here. How to read? A cross B intersection C is equal to A cross B intersection A cross C. So the selection of the sets is our choice. So first step is we select the sets A, B and C. So many elements is your choice. If we take any more elements, it contains one element, two element, three element like this. But if we take so many elements, so the number of ordered pair will be more. So for our easy convenient, I will take just 2 elements in A. 1, 2. Is your choice, sir. I will take 3, 4, sir. Yes, is your choice. B, 2, 3. Next, C is 3, 4. So I will take these elements, or I will take the letters A, B, C like this. So for our easy convenient, I take just 2 elements in all the 3 sets, A, B and C. You see, by taking the suitable sets A, B, C. Here is the intersection involved, and cross Cartesian product is involved. So the common set of B and C, one element is possible. So I will take the sets A, B, C like this. Now to verify this one using these sets. First, in verification, we find the value of LHS. What is LHS? A cross B intersection C. If we need A cross B intersection C, first we find the value of B intersection C. You know very well, intersection means common. What is the element common in B and C? In B and C, what is the common element? 2 is not there. 3, you see both the sets. 4 is lies in C but not in B. So what is the common element in B and C? Just one element, that element is 3. So we write. Next, we find the Cartesian product of these two sets. A cross B intersection C. A cross B intersection C. For understanding, I write the both the sets. A, the value of A is, we will take 1, 2. Cross, okay, cross. B intersection C, the value of the set B intersection C is just 3. You know very well how to write the Cartesian product of two sets. In an order pair, the first element lies in the first set. The second element lies in the second set. So 1, 3. Wow. Because the second set contains only one element. Next, 2, 3. Here 2, 3. So it is a value of A cross B intersection C. So I put it is the first equation. Actually it is a value of the LHS. Now to check the exact answer will come the RHS also. Next we move the RHS. What is the RHS? A cross B intersection A cross C. If we need A cross B intersection A cross C, first of all to find these two sets. Because we need the intersection common of these two elements. So first we find A cross B. That is, a cross means a Cartesian product. So Cartesian product of A and B. What is the values of A? The value of A is 1, 2. Cross. The value of B is 2, 3. So 1, 2, 2, 3. Now we write in Cartesian form. Working rule. 1, 2. One more element is there. So 1, 3. Over. Next we move the element. 2, 2. Okay. Next 2, 3. So this is the values of A cross B. Next we find A cross C. Because we need intersection of these two sets. So to find A cross C. Again, we see the values of A is 1, 2. Cross the value of a C. You see the value of C is 3, 4. Now we write the Cartesian product of these two sets. The first value is 1, 3. 1, 3. Next 1, 4. 1, 4. All the elements are over in the second set. Now we move the next element in the first set. 2, 3. 2, 4. So it is a value of A cross C. So now we find A cross B and A cross C. But what is the RHS? A cross B intersection of A cross C. So we need an intersection of these two sets. So intersection means common. So what is the element common in A cross B and A cross C? A cross C and A cross B. You check what is the common element. 1, 3 is lies in both the sets. Next 2, 3. I take the values. It's a 2, 3. So these two ordered pair only common in A cross B and A cross C. So A cross B intersection of A cross C is the common elements. I take the common elements. The first set is 1, 3 and the second set is 2, 3. I put it is the second equation. Now we check exact is equal to the first equation. You see the first equation 1, 3, 2, 3. Second equation 1, 3, 2, 3. So both are same. So now we come to the conclusion from 1 and 2. The value of A cross B intersection C is equal to A cross B intersection of A cross C. From 1 and 2. Both the RHS are equal, therefore the LHS is also equal. Both are equal. Is the answer verified or is verified? Is a which choice we write in any manner. Our question is to verify. Now to verify all are equal. Is verified or just we write this one. So first subdivision is over. Using the second and third subdivision is important also. 6 subdivisions is there. I will finish the first subdivisions. The second and third subdivision is also involving the Cartesian product using the suitable values of A, B and C. It's better to take the same elements of A, B and C. If you take any values, for your easy convenient, I say in the second subdivision and the third subdivision, in both the sums, is exactly we take the 3 sets as it is, A, B and C. Then to verify both the LHS and RHS answer will come. Or sir, I will try the some more elements, sir. Okay, it's your choice. You will try. For our easy convenient, the second subdivision and third subdivision also will be take the same values of A, B and C. The answer will come easily. Now we move the next subdivisions. Subdivision 4. We already see the second subdivision and third subdivision. How to write. Now the fourth subdivision, some difference is there. It's not a Cartesian product, some difference. How to read? C difference, B difference A is equal to C intersection A union of C intersection B dash. You see B dash. So dash means complement. So one complement set is involved, so we must have the universal set. In a difference symbol, in 10th standard we see a difference symbol is like this, A difference B. Or we say it is A difference. In these two symbol we use any one. We use here A difference B, minus symbol is there. But you don't read C minus. C difference B difference A is equal to C intersection A union of C intersection B dash. So dash is involved, so I will take it is a universal set. And how many sets are involved here? A, B and C. So universal A, B and C. Here also I will take some elements. So you don't memorize the sums. It is your choice, you will take any values. In one or two sums, the difference is involved, so empty set is also possible. So I avoid the empty sets, so I will take these values. Or is your choice, sir, I will take so many values, sir. Other than these elements, so I will take the another elements, is your choice. Here dash is involved, so I will take this U. U is universal set. So elements is 1, 2, 3, etc. up to 8. It's important. All the 3 sets A, B, C is lies within the U because it is a universal set. So the elements A, B and C, all the elements is lies within universal set. So I will take the value of A is 1, 2, 3, 5, 7. Randomly I will take the 5 values. And I will take the value of B is, it's also randomly 2, 3, 6, 7. Difference is involved here. So the values of the elements is there is a relation 2, 3. Next is C 2, 3, 4, 6, 8. 2, 3, 4, 6, 8. So I will take the values of A 3 sets in this manner. And universal set is 1, 2, 3, etc. up to 8. So I will take just 4 values as your choice. But we find some difference. Empty set is also possible. I avoid the empty set, so I will take these elements. But empty set is also possible. So empty set means there is no elements. Okay, using these values of A, B, C and U, now to verify this one. First of all, we will take the value of LHS. What is LHS? C difference, B difference A. If we need C difference, B difference A, first we find B difference A. You know very well what is the values of occur B difference A. B difference A means all the values in B, but the values is not in A. For our understanding purpose, I write B, A. What are the elements of B will be taken? The value of B is 2, 3, 6, 7. 2, 3, 6, 7. A, the values of A 1, 2, 3, 5, 7. When we find the difference for understanding purpose, inside what? We write the two sets B and A. Then we strike out the common elements. So what are the common elements here? 2, 3 and 7. We write B difference A. So what is the first set? B. What are the remaining elements in B? We check. The remaining element is 6. So it contains 6. So it is a easy. Suppose it have A difference B. We write the remaining elements of A. Is a 1, 5. But we need B difference A. So B difference A has only one element. The element is just 6. So over. Next, C difference, B difference. That means all the values in C, but the value is not in B difference A. So here also I write for understanding. What is the first set? C. C. So C contains how many elements? 2, 3, 4, 6, 8. What is the second set here? B difference A. So B difference A contains just 6 elements. Whenever we find the difference, we don't confuse, we write just one side work, we strike out the comma. What is the comma here? 6, 6. What is our first set? C. So what are the remaining element in C? Is 2, 3, 4, 8. So I put it as a first equation. So LHS is Baba. LHS contains 4 elements, 2, 3, 4, 8. Now we find the RHS. What is the RHS? C intersection A union of C intersection B dash. Now we find the union of these two sets. Union of these two sets are needed means first we find the individual sets of C intersection A and C intersection B dash. So first C intersection A. C intersection A means intersection property common. Common in C and A or A and C. In C and A, what are the elements are common? 2, 3. Okay, 2 is common, 3 is common. So no other elements is common here. So 2, 3. So this one is common. Next, C intersection B dash. So first step to find the value of B dash. Next also we find C intersection B dash. So B dash. B dash means all the elements in B, but the element is not in B. So all the elements in U, but the element not in B. So we directly write the value, or for understanding purpose, I write inside work also. U contains the elements 1, 2, 3, 4, 5, 6, 7, 8. And B contains a value. The value of B is 2, 3, 6, 7. So all the elements in U, but not in B. So 2, 3, 6, 7. So what are the remaining elements in U? The values of U is 1, 4, 5, 8. So it is a value of B dash. So B dash, it contains the elements all in U but not in B. So the value of B dash is 1, 4, 5, 8. Now we write C intersection B dash. C intersection B dash. That is the common element in C and B dash. C, the value of C, you see, the value of C, 2, 3, 4, 6, 8. And the value of B dash, 1, 4, 5, 8. So what are the common elements? 4 and 8. Just 2 elements. So 4, 8. So now we write C intersection A union of C intersection B dash. Now using the condition is a union. Union means the element either in one of the sets. So repeat is not possible. So C intersection A. So C intersection A contains 2 elements 2, 3. Wow. And this element is 4, 8. Now I put it is the second equation. Now we see from 1 and 2. 1 and 2. 1, 2, 3, 4, 8. Just 4 elements. The same number of elements is here. 2, 3, 4, 8. So what is the conclusion? From 1 and 2 both are equal. So from 1 and 2. LHS. C difference B difference A. It should be is equal to C intersection A union of C intersection B dash. Both are equal. Or we write A is a verify. From 1 and 2, A is a verify. Or just we write the values. Now I finish the fourth submissions. there will be two more subdivisions, the subdivision 5 and 6. We will take the same values of A, B and C. In subdivision 5 and 6, dash is not involved, all are just involve the three sets. For our easy convenient, I say the same sets A, B and C will be take, then we try the fifth subdivision and the sixth subdivision. The answer is exact will come the same. A cross product is not involved, that is a Cartesian product is not involved. All are involved some difference, union and intersection. And also complement is also is not involved. So no need to take the universal set in the next two subdivisions. That is subdivision 5 and 6. Just we will be take the A, B and C like this. Then we try the subdivision 5 and 6. If you have any doubt, call us. We clarify the doubts. Next we move the fifth one. Justify the trueness of the statement. One statement is given. Our question is whether it is a true or false. So it is a question. So you read the line. An element of a set can never be a subset of itself. So an element of a set can never be a subset of itself. Is it true or false? Is our question. For our easy purpose, I will take one set A. K contains just three elements, 1, 2, 3. What is the one of the elements of A? Is either 1 or 2 or 3. Now 1 is a subset of this one. 1 is an element of A, but 1 is not a subset of A. Here we write 1 belongs to A. Okay, but 1 is not a subset of A. Okay, it is a subset of symbol. But we write let B, it contains only one element. We say B is a subset of A. Okay, the set B is a subset of A. So the element cannot have the subset of the given set. Therefore, the given statement is not true or false. So a set has some elements. So whose element is not a subset, actually is an element. So we can form one more set. The set is a subset of the given set, but the element cannot have a subset of the given set. Therefore, our given statement is, we write it is a false, or the given statement is not true. The same model problem lies in an example also. We must try in our classroom.